We are back. We're back. Welcome back. Now let's get into virtualization. Virtualization is it's really an old concept. It's been around since probably the 60s that computers had the technical ability to be virtualized. And virtualization is nothing new. It's nothing that should alarm you or scare you. It's not that difficult. So when we think about virtualization, what are we talking about? It refers to the creation of a virtual resource, such as a server, a desktop, an operating system, or a network. Now, when we to help calm some of your fears, let's look at a traditional computing environment, kind of like we talked about in the last class, if you remember in the last course, those layers. So your normal traditional computer that sits on your desk, it has hardware, it has an operating system, application. All of those are tightly coupled together, right? Right now, your Windows, you got Windows 10 sitting on top of the hardware, and your operating systems are installed and mounted right on top of that. And it's great. Now, what's some of the drawbacks that made us look at doing virtualization? Well, one, you just got a single operating system, and that's it. So if you wanted to get creative and do something different, like I said, if you wanted to run Linux in your Windows environment, you wouldn't be able to do it. You'd have to completely deinstall Windows and then install Linux, for that to work. Many times, because it is so tightly coupled together, you can have multiple applications running at the same time, and there can be some conflicts between those. Now, this is the big one right here, underutilized resources. What do you mean by that? Well, your average computer, many times, your home computer or your desktop at work, it is probably running, at the CPU utilization is probably running at 3 to 4%. So there's excess capacity in that CPU. Your hard drive probably has storage space. The amount of RAM that's being used, all of it's not being used. So you have these resources sitting there that could be used to do something else. So that's why we started looking at virtualization. So in a virtualized computing environment, you still have the hardware. One thing you have different, we're going to talk about this a little bit more later, is what we call a hypervisor. And now that hypervisor is basically a resource manager. So now I can load multiple operating systems and multiple applications on the same hardware. So it's a better utilization of resources and allows me to do multiple things. So let's go a little bit deeper into this. All right, so again, in this traditional computing environment, we start out with hardware. Now, when we talk about hardware, just like we did before, that's where you got your CPUs. Now, when you think CPUs today, they are multi-core CPUs. You can get 2, 4, 8, 16, 32, 64, if you got the money to spend that. Cores. That's important to know because later on, we're going to see how now I can allocate a core to do different things in a virtual environment. Memory. Like I say, you got a lot of memory. This is your volatile memory, like RAM. Storage. Your hard drives or your SSDs, your network interface, your NIC. This is what allows you to connect to the network. This could be a wireless NIC or it could be a wired NIC. Your input-output device. These are all those jacks on the back. Your USB-C ports where you can plug in printers, mouse, keyboards, other peripherals. So all of this makes up the hardware. Now, on top of that, let's say we're going to install the operating system, Windows, right? And then on top of that, we have our applications. So now that's what that tightly coupled environment, that's our traditional environment. Now let's take this same thing and break it out in a virtual environment. This is what we call a hosted virtual environment, because it's being hosted on a machine with an operating system. So here's our same hardware suite that we had. We're still going to load an operating system. In this case, we're still using Windows 10. However, and now we're still going to load our Windows user applications. So far, everything looks the same, right? Now, here's where it gets a little different. This is when we get a piece of software, VMware, let's say. It's probably one of the largest ones right now that we use across the industry, VMware. But there are some other open source ones like VirtualBox that's free that you can download. Now, that's what we call a virtualization machine monitor, or you hear this term, hypervisor. This is the resource manager that we're talking about. So now what this little piece of software is going to do is first it's going to it creates what we call an abstracted layer. So instead of everything being tightly coupled, and also what it's going to do is going to look at all of these hardware resources, okay, and be able to utilize some of that excess capacity. So now I could go into my hypervisor and say that, okay, I want you to give me access to all of the input output I/O ports. Also access to the NIC, to the network interface card. I want you to set up a virtual space on the hard drive. So let's say I have a hard drive that's got a 1 terabyte hard drive, and I'm only using 200 gig. So I still have 800 gig of space that I can use something else. And so that hypervisor says, yes, I'm going to apportion a part of that, maybe 20 gig, to make it look like it's a separate disk drive. Same thing with memory. I said if I got 32 gig of RAM in this machine. Well, it says, you know what? We're going to allocate 8 gig of this RAM along with this right here to support this virtual environment. And it'll look at the CPUs and says, hey, I want to use one of the cores on the CPU. So it's basically reallocating unused resources in your hardware. So now I can load on top of this other guest operating systems. Because an operating system is just looking for certain things to be able to install. It's looking for a CPU, it's looking for memory, it's looking for storage space, and it doesn't care, if it's physical or virtual. So now that my hypervisor says, okay, I have some extra resources, it's still going to allocate so much for the host operating system and the host applications. But now what's left over, now it's going to say, okay, I'm going to take this, and now I can install, I don't know, maybe Windows 7 or a Linux OS on top of that. Then, once I install the operating systems, now I can install what we call guest applications. Now I can install, Linux applications on top of this operating system, as well as install some legacy applications that I wanted to run. That's why I still wanted to run Windows 7. So now that's how I virtualize this machine. It's called hosted because all of this is hosted on top of the host operating system of the computer. And I recommend, rewinding a couple of times, going back through this because, understanding virtualization from this perspective is very important. It gives you the ability to build on this. But yeah, that's all you're doing. And like I said, if you don't want to spend the money for VMware, Windows comes with its own, if you have a Windows operating system, it has its own hypervisor built in. Hyper-V, I think its name. Or you can go out to the internet, go and Google VirtualBox. That is an open source tool that you can download for free and have your hypervisor. Play around with that. Go ahead, just load one up, and you can always find a Linux operating system, Ubuntu or Mint or whatever you want to, and load that up just to get understanding. Okay, now, like I said, that was how we would virtualize in a hosting environment, like on a single computer. However, in most data centers, this is not how we do it. We have a lot of servers in that environment, so this is called bare metal. We call it bare metal because while it starts out the same, but a server typically is going to have a lot more resources than a single computer. Your CPUs will be running a lot of cores, as well as memory, storage. All of these things are going to be a lot more on that. So now we use typically a different type of hypervisor, which is, this is where you may hear people talk about VMware EXXi. That is the type of hypervisor that we would use here because it has a kernel built into it. As you see, there's no host operating system that the hypervisor is sitting on. It's sitting right on top of the bare metal, but there's a kernel built into the hypervisor that performs the functions of the operating system. So now then, right on top of that, now we can start loading multiple servers. You can have now, depending on how many resources, you can break that server up to run, web services, email servers, print servers, application servers, just a lot of things. So this is how your typical data center would operate in a virtual environment, typically running VMware, like I say, EXXi, some of the larger virtualization tools. Hosted bare metal. Now, another way we do virtualization is application virtualization. The last two we just talked about, that was operating system virtualization. I virtualized the operating system. But now you hear this called containers, okay, where now we're doing really application virtualization, where instead of abstracting the operating system, we're abstracting applications to run the container. We start out the exact same, right? Same environment. And then we have something that we'll install, and you may have heard this term Docker, but there are multiple, Kubernetes is another, that is a container engine. And what that does, it allows us to install just a minimal amount of operating system components needed to run application. Typically things like your binary files, your library files, that's needed for an application to run. For an application to run, it is looking for certain things. But all of these things are encapsulated into what we call a container. And that container can sit right on top of any operating system. It could be on a thumb drive, and you plug the thumb drive in. So you see, it allows us to be able to now port and move containers with applications from one place to another. So it's really good. It's a great tool or a great way of operating, especially in environments now where we're trying to do development, security, and operations in a more agile format. So now I can build these containers, use them, and delete them and keep moving. So it makes security a little bit easier. It makes many things easier in this environment. So I say application virtualization, or you may hear it called containerization. Okay, let's go into cloud computing. I say now we understand how to virtualize. Now that makes it easier for us to move things out of our host environment, out of our local environment, and put them into shared resources or shared services in the cloud. So you hear a lot about cloud, right? Everybody's talking cloud, move to the cloud. Let's move to the cloud. What does that all mean? What does it mean? So when we think cloud computing, where it got its name from, the metaphor for the internet. Because the internet, many times when engineers were drawing architectural documents, they would just draw a cloud to represent the internet, which is really nothing mystical there. It's just all the different servers and storage devices and switches and routers that keeps things moving across the information grid. Like I say, so that's what we talked about. Now let's give you a definition. All right, this is from the National Institute of Standards and Technology. This is their cloud definition. And I want to meet the individual who wrote this. Must have been a big brain guy. A model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, e.g., such as network, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. Whew. I'm not sure exactly what that means. Let me give you my definition of cloud. It's a really cool service delivery model. That's it. That's it. Let me give you an analogy of what I mean by that. Service delivery model. Pre-COVID, before the COVID pandemic, 2019, unless you went to a fast food restaurant, something like that, most restaurants did not have a good ecosystem for food delivery. Many didn't. They may have had takeout where you come get it yourself. But if you wanted to sit home and order food, you had to, either go Pizza Hut, something like that. Those were the ones who understood how to deliver. COVID, and that was their delivery model. You either come to our restaurant, sit down and eat, or you come and pick it up and take it home. With COVID, though, that forced a change in service delivery. Now, almost every restaurant, they've got a little shelf, a little space for Uber, for Grubhub, for all of these businesses now. That's what they do. They cater. They will come pick up your food and bring it to you. The delivery model changed completely. Now, a lot of restaurants are still struggling with the concept because they had to turn that curve, especially if you're a big restaurant and you're not accustomed to billing to-go orders. You don't have the infrastructure in place to manage that, the apps and everything you need. So it's all about how we deliver service. So we're going to talk about that a little bit more about service delivery. But before we do, though, let's talk about how did we get here? How did we get here? Let's look at the evolution of computing. You look back in the 1960s. Those were good years, the 60s. Yeah. Look at the 60s. Really, we started with centralized computing, mainframes, right? And that was a lot of human-to-machine interfaces, where you had big computers in big rooms, and you had these green screen, phosphorus-type monitors that you could interface with those, okay? That's where we started. And then around the 1980s, we went into a distributed environment, client server. Now that's why I have a much smaller server, and I've got a lot of clients connected to that, which is still pretty much where a lot of people are today. You know, you got a data center in your space with a lot of servers and clients. But then we did something interesting in the 2000s. We went back to a centralized model. Yeah, the cloud. Okay, now, so what that is, now in the cloud, we have all these resources and mobile devices that we reach out. For instance, I'm pretty sure most of us have a Google account of some type, either email or whatever. For you to have Google, all you need to do is have access to the internet, right? You don't need to load any software on your platform, on your phone. You just need to have a little button that gets you to the internet. So we went back centralized because Google services are all sitting centralized, kind of like we did in the 60s. And now going forward from that, we're kind of going back to distributed with the Internet of Things and what we call edge computing. Now, a lot more machine-to-machine interfaces. So we still have things centralized, but now what they're trying to do, instead of having everything centralized as a big Google data center, let's push what we need closer to the edge so that people can get their data information much faster. Much faster. At the same time, the Worldwide Electronics Bulletin Board, that's what WEB stands for. And real quick, this is probably a great place to tell you, please do not confuse the internet with the web. They are two completely different things. Okay. The internet, that is the information highway. The web, those are the services that you get along the way. The example I use for that is, okay, I live in Dallas and I want to go to go to Panera Bread. Okay? For me to get to Panera Bread from my house, I've got to get on 635, Interstate 635, and it's 35. Those two interstates. That is the internet. Interstate 35 gets me onto the highway. But I do know that to get to Panera Bread, I got to get off on exit 41. Well, that exit, that's analogous to your ISP, your internet service provider. Your internet service provider, whether it's Verizon or Frontier or Roadrunner, whoever it may be, they're the ones that provide you access to the information highway. Now, once I get off of that exit 41, then Panera Bread is a service that has what I want. Interstate 35 doesn't have anything that I want, like the internet. The internet doesn't have anything that you want. It's the web services. So that is the fundamental difference between the internet and the web. Think of Panera Bread and Interstate 35. And Interstate gets me there, but Panera Bread provides the services. So when we think about the web, it's been building in a generational fashion, from Web 1.0, 2.0, 3.0, and at some point we're trying to move to 4.0, but we're in this 3.0 era right now. So when we think about Web 1.0, what was that? Web 1.0, 1.0, and kind of the .com. It's very static, pretty much read only, and mono-directional. You went to a website and you browsed. That's what it's called, surfing the net. Okay, you went out there and you searched and you saw, what they had. Somebody had some things. Oh, okay. Very static, and it was just some content out there. I used to have a website back then. It was just a bunch of text and maybe a few pictures, but that's about all. So you can go to my website and read and see some pictures. Okay. Now, from there, we move to Web 2.0. This is more people-centric web, participative. It's collaborative, but it's still non-semantic. When we think about semantics, that's where you start putting reasoning and sense and logic to words and to information. So, like I said, Web 2.0, the participative, now becomes bidirectional. So now I got wikis, I got blogs, I got Facebook. We can start talking to each other. Now, before I could just go and see what you had on your site, now you can respond back to me. Now e-commerce starts to pick up because now I can order stuff on your website and you can ship it to me. All these things, I say bidirectional. It's participate. Now we can collaborate with each other. Where we are at the cusp of is Web 3.0, semantic web, that's readable by machines and humans. Now it deals on ontologies. Meaning, okay, what do I mean by that? It's just like now when you go to Amazon and you order something, now machine-to-machine interfaces is able to say, okay, you bought this the last time. You start getting these ads from everyone else. Now they know that you bought this. So now they're pushing web. So now there's, the semantics of what you did is available. Before, in Web 2.0, you just did it. The transaction happened. Nobody knew. Nobody cared. Nobody could even see it. Now, not only does that transaction happen in Web 3.0, now we're able to make sense of it from a big data perspective, like we talk big data. And now I can look at that transaction and from a semantics perspective, this individual, you like chocolate. Well, guess what? For the next, 6 months, you're going to start getting advertisements from Lindell and from Hershey for chocolates. Now, at some point, we're going to, this is out in the future, Web 4.0, the symbiotic web. Now, this is going to be a blended interface of human-machine interfaces. Don't know what that world's going to look like. I don't know. It may be a little scary. Don't know. But that's what we're talking about, with respect to Web 3.1.0, static, read-only, Web 2.0, participative. We could participate. Web 2.0, Web 3.0, semantic web, where now it's readable between machines and humans, and at some point it's going to be a blended interface. So that's how we've evolved with the web. So now that's what brings us to this cloud environment that we know today, from a service delivery, from how things operate in that environment. Because around that Web 3.0, 2.0 environment, that's when we start pushing things to the cloud. Now, when we think about the cloud as a service delivery, right? Well, there's three basic delivery models associated with the cloud. Software as a service, platform as a service, infrastructure as a service. And what do we mean by that? All right, let's go back to our earlier discussions we had on hardware and computers. We had the hardware layer, we had the operating system, and we had applications. You can think of this as being very similar. Infrastructure being the hardware, the operating system being the platform, software being applications. Almost all of us use software as a service. So, if you've got Gmail, Facebook, all of these things are software as a service. You don't own it. You don't have to load anything. You don't have to buy any applications. That software is given to you as a service, those applications. Now, platform as a service is a little different. This is for people who want to be able to develop and build things on their networks, but not have to own the back end. If you've got Office 365, you're getting platform as a service, Windows 365. You don't own it. You're just using it as a service, as long as you have connectivity. Now, you can download applications, but that platform, the operating system, is provided to you. Let's say if you are a software developer and you wanted to develop something for an Android phone. Well, you don't want to have to own, you don't want to own the Android development toolkit. No. You just want to use it as a service, build your particular game or application, and then you don't need it anymore. Same with infrastructure. Do I want to own a lot of hardware if I can get it as a service? No. And give you an example. Let's say you run a tax agency. Now, taxes, in April and usually July, you're going to be busy. So you're going to need a lot more processing, right? So instead of owning your own servers and data center and storage devices that's going to sit there unutilized for maybe half of the year, but then you're going to be really busy the other half of the year using it. Why not say, you know what? I don't want to own it. I just want to have that service. And that's where Amazon, Rackspace, and these type organizations are companies. That's where they make their money. That we can give you, for a cost, the ability to compute. So we own the servers. You don't have to own them. You don't have to maintain them. You don't have to do anything to them. Just like email. Before, I had to own my own Outlook, and I had to keep it patched and updated. No, when it's a service, don't care, because somebody in the back end is doing all the patching, all the maintenance, everything else associated with that. Now, I will say these are the basics, but there are a host of things as a service. Storage as a service. You can get database as a service. XAS, almost everything as a service nowadays. But cloud is really about how you deliver service. Just like with Uber Eats. Do you really care if the guy who brings you your lasagna, if his car breaks down? No, you don't. No. I mean, you have empathy. Oh, man, sorry, that sucks. But if you walked out and his car is broke down in your front yard after he just delivered you food, you really don't care. You really want to go inside and eat, but you'll walk out there, you mean to call you a wrecker? But that's about as far as it's going to go. Why? Because that's a service he's providing, he or she's providing. Now, you drove your own car to Macaroni Grill and picked up your lasagna, and your car broke down. Now you care because you've got to pay for it. So that's why understanding service delivery is so important. However, at the same time, that's why Uber Eats and all of these others have to charge you more, because they have to cover the cost, the risk associated with them providing that service. Now, when we think about those are delivery models. The next part we're going to talk about cloud is deployment models. So it's many times people get these confused. This is the service delivery model. These are the deployment models. 4 basic deployment models. You have a private cloud. A private cloud, like I say, is used exclusively by a single organization or a single entity, and it could be on-premise or off-premise, but it is probably the most secure. For instance, in my home, we have a private cloud. You know, you can buy a storage device today, and you can have your own internal cloud. Another type is public cloud. Like I said, think about Google, think about Amazon. Many of those are public clouds. Basically, anybody can use Gmail. You know, anybody. There's provision for open public use. Reduce costs. Why? Because you got so many people using it on the outside. However, it does, you could have some security issues associated with that. Then we have what we call community cloud. These are provisions for a specific community of users. Hospitals, many times, they have community clouds, meaning that hospitals in a certain region, area, they may all want to be able to access patient information. And those things are kept in a community cloud. It isn't public, it isn't available to everyone, but if you are in this group of individuals, now you can have access to medical information. And probably the most popular is this, a hybrid cloud. That's a combination of any of the 3 above, right? Most businesses operate where they may have a private instantiation, you may have a public front-facing public instantiation, and you could be a part of a larger community. So, you know, really that hybrid is just a mixture of those. Those are your cloud deployment models. Let's look at components, cloud components. Cloud really is pretty simple. 3 basic components. You got clients, data centers, and distribution servers or distributed servers. Clients, that's anything that you probably have in your hand, your phone, a tablet, iPad, whatever it may be. And it could be your desktop computer. But this is the client. Many times these are very lightweight. You know, you don't have anything running, no applications. But the client needs to get to where? Here, data center. Because this is where, here again, this is where the magic happens, in the data center, all right? So how does how does this happen? Well, you're going to need distributed servers. Because now you've got servers that via the internet, your client is going to go to these servers and say, hey, look, I want to get access to this. Then a distributed server, it knows which data center that's hosting that application. For instance, let's say if you got Gmail, and you want to get to your Gmail. Well, when you click on Gmail, it goes here first. And now that distributed server is going to say, okay, I know how to get to the data center, because this could be in, I don't know, Lenore, North Carolina, or somewhere in South Carolina, or in Singapore. But it knows where to go look for the data center that's going to get you there. But you see, it's all facilitated by the internet. Now, you have to have internet connection to be able to do all these great things. But really, cloud components, you know, those are your core components with cloud. Now, some of the characteristics of cloud, like I said, this is, you know, cloud does. It's able to provide you on-demand self-service. You know, as a customer, I don't have to call anyone if to get me to Gmail. Boom, I can get right there. All my capabilities are available across the network, across the internet. I can get to it that way. Resource pooling. Now, this is from a provider perspective. If I'm a cloud provider, I can pool my resources together to be able to serve a lot of tenants. Think of clouds as living. This is living in an apartment complex. Okay, you have a lot of shared resources that the apartment complex owner provides, like parking. That's a shared parking lot. So they're able to gain more efficiencies because they're sharing parking. Many times your mail pickup, you go down, you got one postal area where you get your mail and packages. Again, shared resources where now they can service a lot of people. It makes it easier for delivery because now I have to just deliver it to one location. Rapid elasticity. This is probably the biggest one. When we think elasticity, think about a rubber band that you can stretch and come back, stretch. So if I need to get more services, all I got to do is write a check. If you need more services, it can be provisioned easily. And when I finish with it, I don't need any more. Boom, here you go. You got it back. So that's scaling. You can scale up and down easily in a cloud environment. Measured services. Now, again, this is from a provider perspective. It's easy now to monitor and charge and audit, how much services is it that you're using. Like for instance, if you've got Google and you've got, Google Drive. Okay, you get so much free. You get 100 gig or whatever free. Now you want to go from that? Now we're going to have to sell you, the 2 terabyte plan. Then you use more than that. Okay, now you got to bump it up to the 5 terabyte plan. Measured service, and they can charge. That's how the providers are able to make money. So when we talk about cloud, also we'd be remiss without talking about security, cloud security. A lot of advantages. Because one, we don't own the back end. The cloud provider owns that. So they are able to deploy software patches and updates that quick. As also, they have a lot of redundancy, hardware, software redundancy. We talk about, extended human relations reach. Well, because now in this cloud environment, they can reach out and touch all their tenants, relatively easy. Timeliness of incident response. So when they have an incident, in a cloud environment, the provider is able to respond quickly. And this is a big one. They operate with what we call cyber professionals instead of a pickup team. Why? Because that is their core business. Okay? So for most of the cyber IT guys just walking out of the door of college, and you have your Security Plus, and the ink isn't dry on your diploma, you're probably not going to get a job at Google or Amazon. Okay, probably not going to happen because they are. You got to be pretty top notch to get into the door. So the people that are working on their systems, the IT guys, the cyber security guys, they are top notch because they, Google, Amazon, Rackspace, all of these know that if they have a breach, they're losing money because there's a lot of competition in this environment, so they're losing money. So you get a good team. Some of the disadvantages: jurisdiction. Because in this cloud environment, there is no physical or geographical boundaries. Something can happen your data could be breached at a server farm in Bangladesh. Okay, what do you do with that? Because the legal system in the United States have no jurisdiction in Bangladesh. Multi-tenant risk. Well, like I say, there's efficiencies. We're just like an apartment complex. There's efficiencies, but there's also risk in a multi-tenant environment. Fire. If your neighbor's apartment catches fire, there's a risk that yours could catch fire. If your neighbor's running a meth lab, there's a good possibility that the cops could be knocking on your door just to check. Hey, do you know about this? So that's some of the problems when you run into with multi-tenants. Well, the same thing in a cloud environment, because here again, if you have an instantiation in the cloud, you don't own that server. Your instantiation and probably hundreds of other people are virtualized. They have virtual instantiation on that same server. So if there is a breach of that server, and let's say that one person has done something with their system that now everybody on that server is susceptible to that breach. Vendor lock-in. This is interesting, okay, from a business perspective. You really have to understand your service level agreements in this cloud environment from a vendor perspective. Because when you read the contract, sometimes you'll see that the vendor actually owns the data, your data. So you have to really make good, disfounded business decisions before you move critical data into a multi-tenant environment and just drop it onto AWS or a cloud. Because one, they may not, if you wanted to leave, let's say they went out of business, are you assured that you're going to be able to recover your data and get it back? Huge issue. This right here, this is bigger than all the technical parts of cloud altogether. Is what if a provider fails? And Am I locked into that vendor? Is my data set up in such a way that if I did, even if they gave it back, it's in a format that isn't compatible with another vendor? So now I got to pay someone to reconfigure my data so that they can be compatible. So understanding the business, the service level agreements associated with cloud is by far huge. It's huge. Okay, let's talk about storage, because cloud now, you see how much, when we talk data, a big part of this is storage. Pre-cloud, or in most legacy data centers, this is how storage was done. Very server-centric. You know, server 1, server 2, server 3, and each one had their own thing stored. Now, here's the problem with that. This server, you know, let's say server 1 is for production. Server 2 is for the accounting. Server 3 is for HR. Server 1 and 3, they could be almost filled up, but the one for, you know, server 2 that's supporting contracting, it could only be 8% utilized. Well, and you have no way of load balancing that across these servers. So let's say server 3 that's supporting accounting is full. Now they got to go buy another server, even though there's one sitting in a rack right next to it that's almost empty. Well, that's why now we've moved to what we call information-centric storage architecture. They still have the same 3 servers, right? But now I can build a storage network and have multiple devices to where when I save, it doesn't care which server it sits on. So now I can load balance across those servers. I can still maintain my security, because here at this level, I'm tagging my data. I'm setting up storage security so that if I have data that I don't want to be shared across, I can still protect that. So now this is how, in a cloud environment, that we are actually looking at how we do storage. And you may hear some of these terms, you know, SANs, fiber channel, SCSI, iSCSI, NAS, you know, storage area networks. Fiber channel is where we use, you know, for smaller, smaller distributions where we can run fiber optics, which is really fast, because now we're talking big data sets, so we need to be fast, as well as network attached storage. So now we are more of a storage network as opposed to individual components that do storage. Advantages, disadvantages, scalability, you know, pay as you go. That's why, you know, a cloud environment, they're able to do the metered service like we talked about before. Reliability, yeah, because I got failover. If this server fails, I can now actually start moving things over from one server to another server. Some of the disadvantages, you can end up, like I said, orphan data, meaning that these things can get lost in this environment. Right here, you kind of knew where all your data was. Here, you sometimes have to map data. Or if, like I said, if you're a service provider and someone moves out or leaves and no longer use that service, their data could still be sitting here and you may not know about it. All right, so when we come back, we're going to get into networking, and I think you'll enjoy this.